Hi, today I would like to talk about one specific flow measurement technique called Coriolis. In general, there are a lot of direct and indirect flow measurement techniques. I would say the most famous one would be uh, differential pressure orifice meters, turbine meters, positive displacement, thermal and magnetic meters, and etc. Talking specifically about Coriolis meter, if you look on my slide, you will see that on the right hand side, I'll just highlight it with a pen. I'm showing the Coriolis meter which physically installed in the line or in the pipework, which can measure gas or liquid flow rate. And it also, to mention, it directly measures the mass flow rate. On the left and middle pictures, I'm showing what's inside this thick tube. And inside there, you would usually have either one or two, as on these photos or pictures, or even sometimes four smaller tubes. And in the principle, what you have inside, you have a drive coil just sitting in the middle. Let me also to highlight it with a pen. That's your drive coil, which will receive a usually AC signal and has a magnet as well. So once it receives AC signal, it starts to shake and vibrate and it starts to move up and down, let's say, and it will start to shake and vibrate those two tubes. And then on the right position, and usually on the left as well, you have pickup coils, which is usually magnet with a coil, which measures the movement of those tubes back to the 4-meter transmitter or processor. So just imagine you install the meter, there is nothing flowing through. The drive coil receives the electrical signal and it starts to shake or vibrate these both tubes. When there is nothing flowing through the tubes, gas or liquid, they will vibrate in phase. And that's very important. When there is a gas or liquid flowing through those tubes, then naturally, and this effect called Coriolis effect, they will start to twist. So they will continue vibrating, but they will be slightly twisting in relation to one to another. And that effect called Coriolis. And the amount of twisting or snaking will depend on the amount of gas or liquid flowing through them. Usually, or I mean, it's natural effect. More gas or more liquid you have flowing through the tubes, the more twisting effect will be there detected. And based on this twisting effect, the Coriolis meter actually knows the mass or the fluid which flows through it. If you go to the next slide, in regards to advantages, first of all, the Coriolis meters they are very accurate, I would say, in compared to other meters, and they may be used for physical measurements as well. The accuracy of like well-known suppliers like Kron, Emerson, Andrew Hauser, ABB, and etc. I wouldn't mention all the manufacturers, is around zero point 0.2 to zero point 0.1 error on the measuring range, which is really great. I already mentioned that they directly measuring the flow, the mass flow rate. They're quite independent from the temperatures, pressures, changes in density and conductivity of the gas or liquid. Another point also to mention, the Coriolis flow meter also can measure the density as well. So just imagine you may have a 1 meter which supplies your mass flow rate uh, output to your PLC by one output board. And on the same meter, you can have a second or third outputs, which also provide you density and temperature back to your PLC. And the way it measures the density, it's quite simple as well. Uh, the denser fluid flows through those tubes, the less will be deflection of vibration. It means if the water flows through those tubes, the tubes will vibrate at a certain pattern. But if the honey will be moving, which is very dense in compared to the water, the amount of vibration or deflections of the tube will be much less. So based on that, the Coriolis meters also supply independent density measurements. And also it usually have an inbuilt temperature sensor. So that's why, as I said, it also can supply you with the temperature readings. So basically, by having one Coriolis meter in the wine, if you specify to the manufacturer that you want to measure mass flow rate, density, and temperature, they actually can supply you with a Coriolis meter processor and transmitter with a three independent outputs, which you can link to your PLC or DCS system and receive mass flow rate, density, and temperature, which is fantastic. It's quite, as I said, independent. It's high. It has high density capability. It's suitable for gases and liquid, and it's, as I said, it's very accurate measurement technique as well. In regards to disadvantages, well, it's quite expensive. I have to accept. It's affected by vibration. What that means? Well, Coriolis effect itself, it's based on the vibration, because don't forget the drive coil receives a signal and it starts to vibrate those two sensing lines. So if there is some natural vibration, there is vibration from pump which runs next to the meter, the readings of the meter may be affected by those vibrations. And also installation cost, because you have to insert it in the process lines. So if you don't have a meter which already was installed there, it means you have to actually cut your process lines, install the nozzles, potentially do some weldings, or they can be done offsite and then install it. So that also includes some cost. At the end of my presentation, I want, sorry, to mention on the YouTube video which will following my video. It's very powerful and a great video on the Coriolis flow meters with animation, how it physically works. So I strongly recommend to watch this video as well, please. Thank you very much. Bye, and talk to you later. And I'll try to post other videos on other flow meters or just different instrumentations. Bye for now.
The French physicist Gaspard Gustave de Coriolis set out the physical basis for this measuring principle over 200 years ago. What is interesting is that the Coriolis principle allows the flow of mass to be directly measured. Let's take a closer look at how this measurement method works. A tube is located inside each Coriolis flow meter. An exciter causes this tube to oscillate constantly, here in an exaggerated example. If there is no flow, the measuring tube oscillates uniformly. Sensors are located at the inlet and outlet and register this basic oscillation precisely. As soon as the fluid starts to flow in the measuring tube, however, additional twisting is imposed on the oscillation as a result of the liquid's inertia. Now, due to the Coriolis effect, the inlet and outlet sections of the tube oscillate in different directions at the same time. The highly sensitive sensors pick up this change in the tube oscillation in terms of time and space. This is known as the phase shift and is a direct measure of how much liquid or gas is currently flowing through the pipe. The higher the flow velocity, and thus the total flow, the greater the deflection of the oscillating measuring tube. The application of the Coriolis measuring principle doesn't stop here. It can also be used to simultaneously determine the density of the flowing fluid. To do so, the sensors also register the oscillating frequency. In other words, how often the measuring tube moves back and forth in 1 second. From the animation, it's clear that a tube filled with water oscillates more frequently than a tube filled with honey, for example. which has a far higher density. Thus, the oscillating frequency is a direct measure of the fluid's density. Both the density and the flow are determined simultaneously but independently via the tube oscillation. Endress and Hauser has continuously revolutionized and perfected Coriolis flow measuring technology in numerous innovative systems. This measuring technology is unique, as it's the only way multiple process variables such as mass flow, volume flow, density, temperature, and even viscosity can be measured simultaneously in pipelines. For all applications, we have the right solution. Endress and Hauser, your single source supplier for measuring technology.